exercise, what I'd like to do is just remind you that logs can be found using the calculator, as long as it's a scientific calculator. And then when you go to the keypad, you'll find the button for log. As you can see on this calculator here, there's the button for logs. So if you want log 100, you just press log 100, and on your screen will appear log 100. Know your calculator properly. In my case, I have to press equal to, and then you can see the calculator is saying that the log of 100 is 2. So that's how simple it is. Just press the log button and the number that you want, and you will have the answer that you're looking for. All right, so let's get back. Let's just do one more example. Cancel. And suppose we want log of 1000. Now just find the log button. Log 1000. 1, 2, 3, and then equal to, and you'll see that calculator shows you log of 1000 is 3. Now what you must remember is that the calculator always uses base 10. So if you got any question, what you'll have to do is change the base and make it 10, and then you can use the calculator. So remember that the calculator always uses log in base 10. So you'll have to change base before you use the calculator if the base is not 10. All right, so let's go and do a mixed exercise, and then we will proceed from there with the help of the calculator. All right, so what we're going to do now is we're going to give you a mixed exercise where you will have to use all the different laws. For example, question 1 will be log 25 plus log 4. Number 2, log 200 minus log 2. Number 3, log of 8 to the base 2. Number 4, log of 8 to the base 2 to the index 5. And number 5, log of 1000. Now we're going to take you through a number of examples. We'll do it 5 at a time. Now here are 5 examples, and you are required to do these 5 examples. Alright, let me put the rest. That's 5. I'll put number. I'll go up till 10. So that's 5. Number 6. Log of 100 plus log of 8 to the base 2. Number 7. Log of 64 to the base 4 minus log of 125 to the base 3. Number 8. Log of 5 plus log of 20 plus log of 10. Number 9, log of 5 to the base x plus log of 10 to the base x. And number 10, log of 400 to the base m minus log of 4 to the base m. Right, you have to complete these 10 examples, and remember that any law, you'll have to record all the laws and apply the correct law in each example. Also, you must remember that sometimes you have to recall previous knowledge, think of other sections that you have done, and use any other maths rules that you know also to help you to solve these problems. So simplify these as far as possible. You can even use a calculator to help you when needed. Alright, try them, let's see what you do, and then I will mark them. So let's do this first. 10. So you can take them down, stop DVD, take them down, work them out, and return so that we can mark these 10. Remember that in this 10, you have to apply all 6 of the 4 rules, plus writing in index form, plus writing in log form. You have to use the knowledge, all those 6 pieces of knowledge that you got, plus any other previous maths rules that you know can be applied. Right, go ahead and try it. Right, goody. You have finished the exercise. You're back here. Well, let's see. Now, you know that we got 6 laws. So let me just write the 6 laws here. Firstly, I must be able to change from index to log. Secondly, I must be able to change from log to index. Then third, there's the product law. 4, there's the quotient law. 5 is the power law, and 6 is the change of base. Now it doesn't mean the question is going to come in this order. It can be in any order, and you'll have to use one of those 6, I'll just call them rules, one of the 6 rules to solve the problems. One or more of these rules. So if you look at number 1, clearly number 1 is a product rule. Log of A plus log of B, the bases are exactly the same because the bases are not written. It is understood to be 10 and 10, bases are equal, plus sign, therefore must multiply 25 times 4. So the answer will be log, now 25 times 4 gives you 100 to the base 10. Now log 100 to the base 10, you can now use the calculator and find log 100 on the calculator. You'll press log 100. You must know your calculator, but most calculators should work like this. Log 100 equal to, and you'll get the answer 2. Next one. When you look at number 2, you can see that you've got a minus sign here, and the bases are exactly the same. The bases are not written, the base is understood to be 10. So number 2 is the quotient law. In other words, I'm going to divide 200 by 100. I'm going to divide 200 by 2. I said 100. I'm sorry about that. Divide 200 by 2. So it will be log. Now if I divide 200 by 2, I'll come back to 100 and the base is 10. Well, that answer is also 2. If I put this in a calculator, log 100 equal to, I'll get 2. Now, number 3. I want to know what's the answer for log of 8 to the base 2. And in this exam, I'm allowed to use the calculator. And I've got those 6 rules to help me. So the best thing I can do here is to change the base. If I change the base on this, in other words, I'm using rule number 6. It will become log of 8 all over log of 2. I've changed the base. Now the base is 10 and 10. Now I can use the calculator. So all you do is you take the calculator and you plug in log of 8 divided by log of 2 is equal to, and the calculator will give you the answer 3. So you see, you can't find the answer like this on the calculator because the base is 2. The calculator only works with base 10. So what I did, I took this, I changed the base. And after that, I put this in the calculator. Log 8 divided by log 2 equal to, and I got the answer 3. Right, now let's look at number 4. Number 4, when you read this question, number 4, you can see that you've got a power there. So it's the power law now. Number 5, the power law. In other words, I'm going to bring that 5 to the front here. So that question becomes 5 log 8 to the base 2. Now, in life we say, work smart, not hard. So if you're smart enough, you'll know that you already found this answer here. Log 8 to the base 2, you already found the answer for this, which is 3. But suppose you don't know that, and suppose you're not so smart. Then what you'll do? You'll just do the work step by step, and then you'll say, right. You say, well, there's the 5, and that part there, you'll change the base. You'll say log 8 all over log 2. Now what's happening between these two? Well, actually it is 5 times that. So it will be 5 times that answer. So you put that in the calculator. Log 8 divided by log 2, you get the answer 3. And then it's simple multiplication. 5 3s, 15. So in this example, in number 4, you're using 2 laws. Firstly, you used the power law and brought the 5 to the front. Then secondly, you did change of base on this part. You did change of base. Then you use the calculator to help you to get log of 8 divided by log of 2. You got the answer 3. Then 5 times 3 gives you 15. And finally, the last one, number 5 that was on the board, was log of 1000. Well, that's already in base 10. You simply put it in your calculator. You just press log 1000, and in the calculator you get the answer 3. So those were the answers for number 1 to 5. We're looking at number 6, log of 100 plus log of 8 to the base 2. Now you must be very careful with this question. Don't be tempted. When we pray, we say, Lord, lead us not into temptation. So this example is very tempting, because when you look at the plus sign, you feel you're going to use rule number 3, but you're wrong. You can't use rule number 3 because there is a plus sign, but the problem is the base here is 2 and the base here is 10. So you can't use rule number 3. So what you do, like a TV film, you zoom in and then you zoom out. When you zoom out, you can see that there's 2 parts to this question. You can see there is a part here. Log of 100 to the base 10, which you can find on the calculator. So you can find log of 100 to the base 10 on the calculator. Just press log 100 and you get the answer 2. So that part is 2. You found that one part. Now when you look at the second part is here. Because I couldn't use law number 3 on it, now I'm doing it part by part. On the second part, I can do change of base. So I'll get log of 8 divided by log of 2, which is change of base. Right? Then I bring this 2 down, plus. I put that in the calculator. Log of 8 divided by log of 2, and I get the answer 3. And when I add 2 plus 3, the final answer is 5. So the answer for number 6 is really 5. So what this question teaches you is that don't just try to apply the rules blindly. Be careful and then go back. If you can't use the rule full, then you'll have to study the example and you'll have to do whatever is mathematically correct. I can use the calculator on this part, get 2. I can do change of base on that part. Then I can use the calculator to help me get the 3, and finally add the 2 plus 3 and get the answer 5. So that is why maths is called the queen of all subjects, because it makes you think, and it makes you think about many things. It makes you a divergent thinker, and therefore if you do well in maths, you will be a prized possession. If you go to look for your job, people will be wanting you if you have done very well in maths, because they know that you are a good thinker. Alright, let's move on to number 7. Number 7, you have log 64 to the base 4 minus log 125 to the base 3. Now, when you look at this, you get tempted. You can see a minus sign there. You can see a minus sign there, and you feel you can use 4 quotient law, but you can't because the bases are not the same. So just like number 6, you'll have to do it part by part. So if you look at this part, you can change base here, then you'll have a subtraction, and you can change base there. Get the calculator to help you here, get the calculator to help you there, and find the answer. There are other ways to do it also, but for the moment I'm just showing you how to use a calculator and solve this problem. So if you change base over here, you'll have log 64 over log 4 minus log 125, I'm changing base here also, over log 3. Right, and once you've got that, the calculator can help you here. For this part, log 64 divided by log 4, and you get the answer 3. For that part, log 125 divided by log 3, you put that in the calculator, log 125 divided by log 3, you also get 3, and the answer 3 minus 3 is 0. So the final answer for number 7 is 0. Right, now we have number 8, log of 5 plus log of 20 plus log of 10. Well, this is number 3, because the product law applies, because all the bases are the same. Now you can't see the bases. The bases are understood to be 10. So you are allowed to multiply it. So it will be log of 5 times 20 times 10, which becomes log 5 times 20, 100 times that, 10 gives you 1000. And then log 1000, you use the calculator, put in log 1000, and it gives you the answer 3. So that's the answer for number 8. Right, we'll move on to number 9. Number 9, you had log 5 to the base x plus log 10 to the base x. And when you look at that question, you've got a plus sign and the bases are exactly the same, so you're allowed to multiply. So it will become log of 5 times 10. I'm just doing it step by step. You can do that mentally. It becomes log of 50 to the base x. Now you'll have to stop here. You see, you have to stop there, because I can change base here. It won't help me because the calculator can't take x in it. So this is where I'll stop. I can only apply the product law and stop. Right? Because I can't get that answer, the final answer for that on a calculator, because there's an x here. So that's where I will stop for number 9. And finally, we're going to look at number 10. Alright, so next we're going to look at number 10. So here we have number 10, log 400 to the base x minus log 4 to the base x. The bases are exactly the same. Sorry, the base is m, not x, sorry. Base is m and m. So the base was m and the base is m. So bases are exactly the same. So we can apply rule number for the quotient law. In other words, 400 will be divided by 4. So the answer will be log 400 divided by 4 to the base m. That will become log of 100. 400 divided by 4, 100 to the base m. And that's where I will stop. I can do change of base here, but it won't help me in any way. So that's why I will just stop. That's the answer for number 10. Right. I'm sure you're getting the feeling now, and you're seeing how the different laws apply in the different examples. Right? I'm now going to give you number 11 to 20 on the board, and then you can try number 11 to 20. Alright, here's the rest of the exercise, number 11 to 20. Number 11, log of 100 to the index m. Just apply some law and rewrite it in another way, or if it can be simplified, simplify. Number 12, log of b to the base a plus log of b to the base a. Number 13, log of m to the 4 to the base x minus log of m to the 7 to the base x. Number 14, log 4000 minus log 1000 plus log 125. Number 15, 5 minus log 100 minus log 1000. Number 16, log of 8 to the base 2 minus log of 32 to the base 2. And I think I'll put number 17 to 20 on the other side there. Number 19, you've got log of 1024 to the base 2 times log 8 to the base 2. And number 20, you got log 1000 divided by log 100. Right, that's number 11 to 20. Take them down, stop the DVD, try them, and then come back so that we can mark them. Alright, welcome back. So we're marking number 11. So in number 11, all you can do is just use the power law, that's all. So it will become, and according to the power law, m will come to the front there. M will come right to the front, so another way to rewrite that would be m log 100. Now, when you look at this part here, log 100, you can get that answer from the calculator. So you just press log 100 in the calculator and you'll get m times 2, because this means m times log 100. So m times 2, and the final answer, well, m times 2 is 2m. Right. Let's look at the next one. There's a plus sign and both the bases are exactly the same. Therefore, I can multiply these two numbers. Now this is b and that is b. So if I multiply b times b, I will get b squared. So this answer is log b squared to the base a. You see? B times b will give you b squared, right down the base a. Now if you like, you can rewrite this, you can bring that 2 to the front now, so that you're practicing as many laws as possible. So that will become 2 log b to the base a. You see, first I use the product law, I've got this. Then when I saw this, I'm using the power law and bringing the 2 to the front. The whole idea is to get practice with as many laws as possible. Number 13. Well, let's see. We've got a minus and we've got the bases exactly the same. Therefore, I can use the quotient law. So the answer will be log. Now it will be m to the 4 divided by m to the 7. So you've got m to the 4 divided by m to the 7 and the base is x. Now, m to the 4 divided by m to the 7, remember your power laws, write down the common base, subtract the indices. Subtract the index where the index is bigger. So the answer will be log 1 over m cubed to the base x. Right? We generally like to write it like that with a positive index. But there is another answer for this. Another answer for this will be or log m to the minus 3. You see, if you subtract it on top, 4 minus 7, you'll get m to the minus 3. In that case, what you'll do, you will bring the 3 to the front here. So it will become minus 3 log m to the base x. So we've got two answers. You can write it like that or you can write it like that. Okay. Number 14. Now, if you read number 14 carefully, these two will be divided. It's a quotient law, you see? So you divide this two, get the answer. So let's do it step by step. Let's just do it step by step. Number 14. Right. So if I do the first part, I will get log of 4,000 divided by 1,000. And I don't have to worry about the base because the base is understood to be 10. And that part is log 125. Now this part becomes log of 4 plus log of 125. Now we use the product law here because the bases are the same. You end up with log of 4 times 125 is log of 500. Now you can put log of 500 in the calculator and get the answer correct to 1 decimal place. So if you put log 500 in your calculator, log 500 in your calculator and press equal to, you will get the answer 2,698, etc. It's rounded off to 2,7, correct to 1 decimal place. So we round that off to 2,7. All right. Right, now we're having a look at number 15. We've got 5 minus log of 100 minus log of 1,000. Well, this is simply 5 minus log of 100. You check in the calculator, you'll get 2. Minus log of 1,000, you check in the calculator, you'll get 3. And 5 minus 5, final answer will be 0. It doesn't mean you have to apply rules all the time. You can apply common sense also. So in this example here, we're just applying our common sense and getting the answer. Number 16. Log of 8 to the base 2 minus log of 32 to the base 2. Now, the bases are the same. The bases are the same and there's a minus sign. So the quotient law will apply. But you must be careful. A lot of students get caught with this. So there's the 8. 8 will be divided by 32. And the base will be 2. because the first number is a numerator, the second number is a denominator. And so that will become log of 8 over 32. If you put it in the calculator, you'll get 0.25 to the base 2. Or you'll get log of quarter to the base 2. Right? So, if you want, you can continue with this. I can change base. If I change base here, I'll get log 0.25 all over log 2. I'll change base here. Log 0.25 all over log 2. And then I put this in the calculator. I put that in the calculator. And when you put that in the calculator, you take your calculator and you say log 0.25 divided by log 2 is equal to, and you'll get the answer minus 2. So number 16, you're using two laws. Firstly, using the quotient law up till here. And then when you simplified that, you came to this. Then you changed base. You used the law change of base. You changed the base so that the calculator could help you now to get the final answer. So sometimes in an example you'll use more than one law. Right? We're going to move on to number 17. In number 17 we have log of 10 minus log of 1000. But once again, you've got two choices. You can use common sense and get the answers. But let's say you wanted to use the law and you said, well, this will be log, there's a minus sign, bases are the same, therefore it will be log of 10 over 1000. And that will work out to log of 1 over 100. So, when you're putting this in the calculator, it's better for you to put that in a bracket, you see. So, you want the log of 1 over 100, and you put that into the calculator, right, like that. Or if you want, you can simplify it. That becomes log of 0, 0, 1. If you simplify this part, it becomes, if you simplify that part, it becomes 0, 0, 1. And then you find that log in the calculator. And when you take your calculator and you put in the log 0, 0, 1, you get the answer minus 2. So that's minus 2. Move on to number 18. Number 18, you've got log of half to the base 2. Now you've got log of half to the base 2, and you want to simplify this. You want to use some rules. So I can change base. So if I change base here, it will become log of half over log of 2. And then I just put that into the calculator. Log of half divided by log of 2. Right? Again, sometimes you might just make a mistake. So it's better for you to write this as log of 0, 5 over log of 2. It's better to write it like that and then put it in the calculator, because half is 0, 5. Log of 0, 5 over log of 2. Take your calculator and say log of 0.5 divided by log of 2 is equal to, and you get minus 1. Once again, I must remind you, there are other ways of getting this answer, but we're just showing you how to apply the rules and get the calculator to help you to find these answers. Right, we have to do number 19 and 20, and we're coming there shortly. Number 19, you have log of 1024 to the base 2 times log of 8 to the base 2. Now, you must read very carefully. Log of 1024 to the base 2 times log of 8 to the base 2. The bases are the same, but there's no law for multiplication. The law is for a subtraction sign, and the law is for, in other words, the two laws are log of A plus log of B. So there's a plus sign in between, and the other law says log of A minus log of B. So there's a plus sign and minus sign, there's no multiplication. So don't get caught in the trap. So you can't use those laws. You can't use that law because of the multiplication sign here. All of the bases are the same, but there's a multiplication sign, not a plus sign. So once again, use your common sense and use your previous knowledge of maths, and you say, right, I can do this on its own, I can do that on its own, get those two answers and multiply the answers. So if I want to do this on its own, I can just change base. So it will become log 1024 over log of 2 times log of 8 over log of 2. You see, I'm changing base on this part over here. I'm just bringing down that sign, and I'm changing base over there. Now I put this into the calculator. So you take your calculator, right, make sure you clear previous work, and you say log 1024 divided by log 2 is equal to, and for this part I get the answer 10 times. Then you go to that part, take your calculator, clear your previous work, log 8 divided by log 2, and the answer is 3. So finally it is 10 times 3, and the final answer is 30. And finally we have number 20. You have log of 1000 divided by log of 100. Once again, don't fall in the trap. You see, the law says it can be log of A plus log of B plus sign, or it must be a minus sign, but this is a division sign. So I can't use those laws. Again, it's common sense. Well, log of 1000 you can find in the calculator. Just put it in there and you'll get the answer 3 divided by log of 100. Just put it into your calculator and you'll get the answer 2. You just put log 100 equal to and you get 2. Now 3 divided by 2, put it in your calculator, you'll get 1.5 or 1,5. And that's your final answer for number 20. Right. So if you want to say you know your work, you must be able to do from number 1 to 20 and get them all right without any hesitation, without any doubt. And you should be getting them right at high speed. And so in other words, you must develop speed and accuracy. So you can go and redo the exercise again so that you can test your speed and your accuracy in case you made some mistakes. If you had got them all right the first time, well done. Alright, so in our next session, what you should do now is take a break once again, go and relax, etc., and come back, and then we'll do exercise 2 or a mixed exercise where you will have to solve some log equations. You can get equations in logs, and that's what we will be doing in the next session. Is do a little example on a simple equation. Do an example on a simple equation and thereafter give you an exercise. Let us suppose you have this example here, that log of 16 to the base x plus log of 8 to the base x is equal to 7. Let us suppose you're given the simple equation here. Log of 16 to the base x plus log of 8 to the base x is equal to 7, and you are required to solve for x. what you will do then is you will just apply the log laws. You got 6, I will just call it 6 laws or 6 rules at your disposal. You got 6 rules, you can use them. Right. So you can see that I'm allowed to multiply these two. So you will say, well, that's log of 16 times 8 to the base x is equal to 7. So you'll say that's log of, take your calculator and multiply 16 by 8. So you'll say, well, on 16 times 8 is equal to 128. 128 to the base x is equal to 7. So far you've used the product law. You've come up till here. Now when you come to here, this is log form. This is log form, log form. What you do now, you can change it to index form. So to change it to index form, you'll say, well, 128 is equal to x to the 7. 128 is equal to x to the 7. Now you remember from powers. Now 128 is a power of 2. You see? If you take powers of 2, 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8, 2 to the 4 is 16, right? 2 to the 5 is 32, 2 to the 6 is 64, 2 to the 7 is 128. So this is really 2 to the 7 is equal to x to the 7. Now, see, from there you can convert it to index form, right? And then now you're trying to solve for the base, you see. So what you do, rewrite this as a power. You got 2 to the 7. Now the indices are exactly the same. Therefore the bases are equal. So the answer is x is equal to 2. Right? So you came there, rewrite that as a power of 2. Okay? Because you can see that is something to the 7 and 128 is 2 to the 7. So you will have to know your other sections properly. If you don't know your other sections, then you will have a problem. Right? Or another way to do this one will be, this is one way. Another way to do it will be, you came up till there, right? You came up till there. So you can even change base if you like. You're going to say log of 128 over log of x is equal to 7. So that 7 will be 7 over 1. And you can cross multiply if you like. So log of 128 is equal to, if I cross multiply, 7 log x. Right? So then using your, right, so now log of x, you can divide this by 7. You see, I'm getting rid of the 7 now. So log of x is equal to log of 128 divided by 7. And I'll put this in the calculator. See, you take log of 128, log 128 divided by 7, and you get 0,301. You get 0,301 is equal to the log of x. Right? Okay, so now you've got here, so I'm going to take this across over here. So you got log of x is equal to 0,301. That's what you got here. You got log of x is equal to 0,301. What's the base here? The base is understood to be 10. So I'm going to rewrite that in index form. So x is equal to 10 to the 0,301. So x is equal to, now you put that in your calculator. You put that in your calculator and you say that's 10 to the index, depending on your calculator, right? Y to the x, 0.301 is equal to, and you're getting 1,99999, 1,99999, and if you round that off, it's going to be 2. So that's the other way. You got a choice. Know your power tables, or you can go like that. Right? So you got two choices. Alright, so what I will suggest to you is that, look, maybe this is a little bit complicated for you. Well, the choice is yours. You've got two choices. What I'm going to do now is I'm going to give you an exercise, and you'll find the things in the exercise will be much more easier and simpler and faster flowing than what I have done. But I've purposely chosen something that is a little bit of a challenge for you. Alright, so let me give you an exercise and you can try it. But before we do the exercise, what we're saying to you is that, look, when you get a question, apply some basic law. In this case, we did the product law. Once you've got the product law, simplify, change it to index form, recall your powers, and then solve. Remember, if the indices are the same, you can make the bases equal. Remember the other rule, if the bases are the same, you can make the indices equal. So there's two rules, you see. If the indices are the same, you can make the bases equal. If the bases are the same, you can make the indices equal. That is something you learned under powers. Alright, let's give you an exercise and then you can try that and we'll take it from there. Alright, we're on exercise 8. Let's say log of 100 minus log of 10 is equal to x. Then we'll give you number 2, log of x to the base 5 plus log of 5 to the base 5 is equal to 4. Number 3, log of x to the base 2 minus log of 4 to the base 2 is equal to 32. Number 4, log of 4 to the base x plus log of 16 to the base x is equal to 2. And number 5, log of 16 to the base 2 to the index x is equal to 40. Alright, let's do this 5 first. Stop the DVD and try it, take it down, try it, and then come back to us to mark them. Alright. So that was number 1. So when you looked at this question here, you said, well, this is A minus B, so I can use the quotient law and say that's 100 over 10, and the base is understood to be 10 is equal to x. And that simplifies to 100 divided by 10 is 10, 100 divided by 10 is 10, and there's the base 10 is equal to x. Now you've got two choices. You see, you can put this in the calculator straight away, as it is. The log of 10 to the base 10, you just put it in the calculator and you get 1. So 1 is equal to x, and you have finished solving that. So in this case it was very, very simple because it was in base 10, so that's the end of story. Right? Let's look at number 2. Number 2, you had log of x to the base 5, log of x to the base 5 plus log of 5 to the base 5 is equal to 4. Now remember, there's many ways to solve these equations. So, let's suppose you saw this and you told yourself, well, I'm going to multiply. You know, there's A plus B and there's 5 and 5, so it will be log of 5x to the base 5. You know, using the product law, multiply these two numbers. So there's 5x, there's the base, is equal to 4. And then when you saw this, you said, well, it's log form, let me change it to index form. And you said, well, if I send that there, I'll end up with 5x is equal to 5 to the 4. That means 5x is equal to 5x to the 4, you put that in the calculator. You take your calculator and you say 5 y to the x 4 is equal to, and you get 625. Now 5x is equal to 625. X is equal to 625 divided by 5. 625 divided by 5 is 125. So x is equal to 125. So like I promised you earlier on, these are equations and they're much simpler than the ones that I did in the